Assalamu alaikum students. This is first lecture of a new topic, sound. So as we have studied that sound is a longitudinal wave, as the propagation of sound wave is along the in the direction along or in the direction of the vibration of the particles. So sound is a form of energy which is transferred from one point to other in the form of waves. And you must also know that a sound is produced by the vibrations. Like we can see the diagram. We have a tuning fork. Tuning fork is a device or an instrument that is used to generate the tone. Tone is a sound wave that has only single frequency. So when you strike this tuning fork with some hard material or some rubber material, especially, this instrument start vibrating, and which produces sound wave or tone. So in the figure you can see that there are two portions of this sound wave. Number one, compression is represented by C, and R is rarefaction. Where the molecules are closer, this portion is known as compression, and where the air molecules are far apart, this is known as rarefaction. Or you can also say that where the air pressure is highest, the point is known as compression point, and where the air pressure is lowest, the portion or the point is known as rarefaction. So sound waves travel in the form of compression and rarefaction. The vibrating pawns of the tuning for compress and rarely and rarefy the air molecules, and sound waves are sent out. So basically, sound wave is a pressure wave. So it means you need a medium in order to travel the sound waves. Compression, what is compression? Compression is sound wave is the region in which the molecules of medium are closer, and a rarefaction is the region in which the molecules of medium are further apart. So why is it a longitudinal wave? Since the compressions and rarefactions travel horizontally, you can see in this diagram, compression, and this one is rarefaction, and the direction is along horizontal axis. Similarly, the direction of the wave motion or the propagation of wave is also along horizontal. So when these directions are parallel, to the wave is known as longitudinal wave. So how to find the wavelength of this sound wave? It is very easy. Just calculate or just measure the distance between two successive compression points. Or you can also find this lambda by taking the distance between two successive rarefaction portions. Clear? So it means one compression and one rarefaction. The distance between these 2 points gives you lambda by 2, or half of the wavelength. So as we have studied that sound waves need medium to travel through. So I'm going to demonstrate with this theory with some experiment. So sound waves require a medium in order to travel from one point to another. Since sound waves travel in the form of compression and rarefactions, if there is a vacuum, then no compression rarefaction are produced, and sound wave is not transferred. So you can see this diagram. It's actually a jar made of glass, and this is open end which has been closed by a rubber bung, so that the sound waves produced inside this bell jar do not travel outside. And this is vacuum pump. In the start, when you turn on this switch, or this is switch, or close the switch, the current passes through the uh, bell, and bell starts ringing, and you can clearly hear the sound that travels from inside to outside. But when you taking the air out of this bell jar by this vacuum pump, you will observe that the sound wave become faint or softer. So when the air is completely pumped out, no sound is heard from the ringing bell. So why is this so? Because sound waves need medium to travel through. So there is no air left now. So it is vacuum inside. So sound wave which is produced by this bell cannot travel through the vacuum. So you cannot hear any kind of sound outside. All right. This experiment has explained that sound waves need medium to travel through. It can be a gas or liquid or a solid. So this is the end of this lecture. You have to revise this lecture in order to reinforce the concepts that we have studied today. Okay, take care. Allah Hafiz.